Hello, everybody, and welcome to this episode of Into the Impossible podcast. Today's guest is Professor Paul Sutter, who is an amazing, highly passionate, hilarious, energetic, effervescent astronomer who's really turned most of his intellectual endeavors to the realm of public science communication. He's involved with Emmy-winning productions and media, dance troupes, but he's a hardcore scientist too, and I learned a lot from him. I agree with him on a lot of things. I found it fascinating to hear his perspective on whether or not scientists should basically be forced to learn how to communicate as we learn how to communicate or learn about quantum mechanics. Should we not have an obligation to bring our research, our findings, our passion to the general public because you guys pay our salary? So anyway, I want to ask you to subscribe to the podcast. Just hit that little bell over here, over there. Whether you're watching on iTunes, listening on iTunes, or watching on YouTube, please subscribe and leave a rating because actually the algorithm is truly based on the number of comments, likes, subscribes, etc. That we get. So the more we can do that, the more great guests we can get. Stay tuned for coming future great guests, including Nobel Prize winners and losers and all sorts of fun things coming up, including a live stargazing party with Adam Rees, Nobel laureate, Wendy Friedman, and others on November 10th, 2020. And if you're listening to this in the future and the world has not been destroyed, the universe has not come to an end as documented the many different ways it can be documented in this book by Paul Sutter, today's guest, How to Die in Space, then I will see you in the future. For now, signing off and imploring you to enjoy going into the impossible with Brian Keating.
Any sufficiently advanced technology is indistinguishable from magic.
Welcome to the Into the Impossible podcast. I am your fearful host during these pandemic podcasts. And today we have Professor Paul Sutter. Am I saying it right, Paul?
It's Sutter like butter with an S.
All right. And you're silky smooth. My mother used to say, you're so smooth, you're so cool that butter doesn't melt in your mouth. So that's how I'll remember it. There's this book by,
Thanks,
I think,
Mom.
Jonathan Foer called Moonwalking with Einstein about how he became the world's memory champion, U.S. memory champion, I forget. But that was by memorizing. You take someone's name and you equate it to some physical characteristic. So now I will never make that mistake with Professor Paul Sutter. No, I'm just kidding. Sutter like butter. PhD, Dr. Paul Sutter. How are you doing today, sir?
I'm doing fantastic, especially given the climate we're in.
I know, it's kind of crazy. I'm hoping to have this podcast out after November 3rd, if November 3rd does not result in another way to die on Earth. And I want to get into that. But of course, if the Earth doesn't die, but maybe, some of these things that you talk about, these deadly phenomena of the extraterrestrial world aren't looking so bad compared to some of the stuff going on this terra firma.
You know what? When Venus looks appealing, we really got to reconsider.
I know. I'm looking for real estate there. So where are you calling us? Where are we speaking to you over the phone lines at this moment? Are you at the CCA? Where are you located currently?
So I am based out of New York City. I'm in my home office right now. And like you mentioned, the CCA, I do have a visiting position at the Flatiron Institute's Center for Computational Astrophysics. And also I am a research professor at Stony Brook University's Institute for Advanced Computational Science, which is way better than the Institute for Basic Computational Science.
Or advanced studies. It's like, what are they doing over there? They don't even know what they're studying. These guys, I talked to these guys,
not doing it.
Scratching it. Yeah. Well, you may or may not know, Stony Brook is my ancestral homeland. I was born at the State University of New York, right there. My father was a professor of mathematics, along with Jim Simons, who was the founding chairman of the math department. It
is now super rich.
Yes, and it is now called, you've gone a rebranding. It's now Stony Brook University, which is very different, radically different from those of us
trying to be cool, fit in with 21st century.
Yeah, SUNY was too confusing, I guess, for other people. But anyway, shorter is better. And I keep, whenever I read the title of this book, I have this song that goes through my mind, and I can't get it out of my mind, but it's like how to get along or like how to die. Anyway, I've been singing how to
I'm
die
gonna leave that to you.
yeah, I've
I
been
will not
singing
be
how to die in
doing backup on
space.
that.
That's right. Let's ask a spaceman, not ask a musician. What inspired you to write this book? As last I checked, we're not that likely to even get off the Earth anytime soon, let alone to go to the heart of Sagittarius A star. So tell me, what inspired you to do this?
Yeah,
What did the
yeah.
publishers say when you pitched this book proposal to them?
When I pitched this book, I said, look, I tell all these stories in my podcast and media appearances and everything, and it's just fun. And the whole point of the book is to explore this amazing astrophysics on all sorts of scales and all sorts of locations in a really fun, lighthearted way. The whole point of the book is to have an excuse to talk about awesome astrophysics. Just saying, like, here's a book about astrophysics isn't going to sell a lot of titles to publishers or the general public. But then if you say, here's how you can die by learning about astrophysics, like that gets people interested.
Now, I remember, reading, and my wife asked me, why are you reading a book about how to die in space? And I was driving on a long drive with my kids, and I had the choice of, putting on a podcast, one of my podcasts, or listening to the audiobook as I did of How to Die in Space. And they're like, turn this podcast off. We want to know how you're going to die in space. Yeah. And it just so happened my 7-year-old was very curious about the very first chapter was actually perfect for him. He was actually wondering about, how long would you immediately die if you go into space, as this cover artist has, and you don't lose your head as this guy's losing his head. I don't know. We'll flash it up on the post-production. But if you took off your helmet, are you going to die as my 7-year-old suspects?
Yeah, you're going to die, but not right away. The first thing that's going to happen to you is once you're exposed to vacuum, all the air in your lungs is going to go out. And don't you dare try to hold it in, because your throat and those little slimy muscles are not designed to hold in a lung full of air against vacuum. So the best thing you're going to do is just let the air go. If you try to hold it in, you will damage your lungs. You will damage your throat. It is going to be bad news. So you just let it go. Now, and then the second thing that's going to happen is that all the oils and moisture on your skin and eyeballs and tears and sweat and everything are going to instantly evaporate or sublimate into space. And just that's going to cause a little bit of damage, a little bit of burning on your skin, but you're okay. The big thing that gets you is the lack of oxygen. That's because your heart is still pumping, blood is still flowing through you all the time, doing its thing. It just stops carrying oxygen because there's no air in space, and so there's no oxygen. So in about 10 to 20 seconds, your brain is going to shut down. You're going to lose consciousness. You can be recovered if you're pulled back in, and you can live a relatively normal life. But if you stay out for a few minutes, then as your organs start to lose oxygen, they will shut down. And then when all your organs shut down, you are dead. So it takes a few minutes for you to die in space when exposed to vacuum. It's not instantaneous, and you really only have a few seconds of self-propelled maneuverability to get you back into safety.
So it's far more excruciating than some of the other ways that we recount. And at the end, I'm going to ask you of your preferred method of dying. But first, before we get to the end, as it says in Ecclesiastes, better is the end of a thing or a person than the beginning thereof. But there's a certain poem that I read. It's a long poem. It recounts the epic of a bearded sailor traveling across time and recounting his travels at a certain wedding ceremony. Now, my father and Jim Simons used to enjoy their time on Long Island Sound on small fishing craft, at least until one of them capsized it. I won't get into that. But the Ancient Mariner has a rhyme as well. And in this book, there's a lot from a certain character named the rhyme of the Ancient Astronomer. I want to ask you, who is the Ancient Astronomer, and is he bearded?
Yes, each chapter opens with a few verses from the what's called the Rhyme of the Ancient Astronomer, which in the setting of the book takes place in the far future where interstellar travel is easy and cheap and lots of people want to do it. And the character, the persona that I take on when I'm writing the book is from like a grizzled interstellar travel veteran who is, oh, you want to go into space? Well, let me tell you why you shouldn't, because it's long and arduous and dangerous and difficult and also full of wonders and beauty and discoveries. And so I imagined in that far-flung future that there are collections of sayings and stories and phrases that have been passed down through the eras where no one's exactly sure who wrote it, when they wrote it, if multiple authors were involved, where it's just a collection of sayings to guide people through the universe. And it turns out they're almost always cynical.
Yeah, I was wondering about that, and also what the H index is of the ancient astronomer. But I won't get into that right now. I want to ask you, on the back of the book, it says Paul M. Sutter, PhD, is the author of Your Place in the Universe, Understanding Our Big, Messy Existence, as well as the host of the Ask a Spaceman podcast. He's currently a research professor at SUNY Stony Brook. Incorrect. Well, they say there's typos and this should not be quoted. So this is the advanced reading.
It's fine. You're allowed to say SUNY Stony Brook State University of New York at Stony Brook, and also Stony Brook University.
How refined.
Acceptable brandings.
We are not allowed to say UCSD anymore. It's gets confused with a neighbor to the north that shall remain nameless. But then you're also a guest researcher at the Flatiron Institute. If a ancient astronomer happens to time travel back to New York City and wake you up at 3 a.m, you do all these amazing things, all these interesting things, hardcore scientific research, popular outreach, popular writing, scientific writing. Who are you?
Who am I? First off, if a time traveler teleports into my home at 3 a.m., I am calling the police. I don't care what they say or what era they claim they're from or what newspapers they're holding. We are getting the police involved.
I think de Blasio might shut that down. I don't know if you're allowed to get rid of him.
I'm gonna work on it. Listen, we're gonna get some firepower involved. Now, who am I? Yeah, so I'm an astrophysicist. I got my PhD back in 2011 at the University of Illinois at Urbana-Champaign. I'm working in giant computational simulations of stuff flowing out of giant black holes inside of clusters of galaxies. Then after I got my PhD, I went to the Paris Institute of Astrophysics, where I worked with Ben Wendelt on voids. I was a member of the Planck collaboration, studying the cosmic microwave background, which you are a little bit familiar with, and doing all sorts of cool analyses of radio interferometric techniques for the first stars. Then in 2014, I moved on to a second research position based in Trieste, Italy, where I continued those research lines.
Who'd you work with there? I have a lot of good friends there. Carlo
Beccoli. Matteo Viel was my sponsor there, but I was largely independent. It was a fellowship, so I was working all over with everyone.
Nice.
Yeah, and a bunch of the people that I've encountered in Paris and Italy are now actually working at the Flatiron Institute, so it's good to see a bunch of old friends again. And it was in the course of that second postdoc where I started my podcast, which is still running. It's called Ask a Spaceman. We're on episode like 140 something now. And it was just an experiment. It's like, I like doing outreach. I liked giving talks. I liked answering people's questions. And I wanted to put something out there in the world. And I thought, okay, I'll just put it out there. I'll just do it. I'll just see if it's any fun. I'll see if I enjoy it. I'll see if it resonates with anyone. It turns out it kind of resonated with people. It turns out I really enjoy it. It really grew. I got a solid audience base right away, or after like 6 months or a year of dedicated work in it. I got a great audience. That opened up other opportunities to start writing, to start hosting, start doing other things. And slowly over the course of the past 5 years, I've transitioned from being fully embedded in professional research with a little bit of outreach to now where I'm doing almost entirely science communication and outreach with a little bit of research on this side. So I still work on cosmic voids and large scale structure. I'm still a member of some collaborations, and but the majority of my time is spent doing this, is writing books and writing articles and hosting TV shows and doing silly YouTube videos and making up lame jokes to put on social media and doing interviews with other people like you, and just having a blast.
Yeah, it really shows in the book. And I listened to the audiobook and read the physical book, and I advise everybody to do that. And for the hat trick, as we say, throw in the electronic book issue as well. You got to have all 3 copies, all 3 versions. But you narrated the audiobook, which is something I did not have.
I had to audition for that.
I know. I was going to ask you about that. You do have a mellifluous voice, honed over many, many episodes of Ask a Spaceman, and probably some imbibations, perhaps some libations.
Just water, man. I keep it clean.
Yeah, me too. Yeah, me too. Of course. But it really comes through in the book and the audiobook, and certainly that you have this infectious passion for doing this. And it kind of brings up one of my next questions is about. What is the obligation? I'm going to be provocative. I'm going to be, a Fox News host here for a second, if you'll indulge me.
Hey, I'm going to say that. It's cool. Let's go down that rodeo.
Yeah. So I think scientists, they get paid by the public, except if they work for a large institute such as yourself, or have a $100 million project funded by the same individual. But anyway, we work for the public. Joe taxpayer, Joe Sixpack. First of all, why should he care about anything you talk about in your book, millions of years in the future, perhaps? That's my first provocative question. Why should we care? And then I'm going to get a little bit more personal about scientist obligations. But first, why should Joe Sixpack, Joe Bag of Donuts? I don't know why his name is always Joe. Let's call him Clement. Why should he care about all this
Bag
stuff?
of Donuts. Hello, Mr. Bag of Donuts. I hope you support me in the upcoming election. No, you should care because this is fun. You should care because this is interesting. You should care because trying to figure out how the world works is a part of who we are. No, astrophysics, like figuring out how black holes work or the earliest moments of the universe, it's not going to make more efficient car engines or faster internet. It's not going to change your material life, but that was never the point of science in the first place. The point of science is that we are curious. We are a curious people. We are a curious species that defines us. Art and music and dance and curiosity are all a part of who we are, and science is an expression of that curiosity. So you should care, and I'm eternally grateful for your taxpayer support to keep science going. I recognize that this is a privilege of scientists to be able to do what they do. Science does lead to great technological advancements. That's more of a fun byproduct than the main point. But you should continue funding science, and you should care about what astronomers are doing, because it's fun to learn new things. It's fun to explore and discover and be curious. And so you can read my book, and this book is the result of hundreds of years of trying to figure out how the universe works. And if it surprises and delights you and you enjoy it, then you are participating in the very reason that science exists.
Indeed. Now, along those lines, let me keep on, let me go to his wife, Clementine, Bag of Donuts. And so you scientists—
What a coincidence.
have this amazing privilege. You're in your ivory towers, et cetera. How come you're good at it, Paul? You're a brilliant communicator. You have obvious infectious passion and joy in everything you do. How come, the researcher at the state college down the street, how come she's not doing it? Shouldn't she be forced to do it? Shouldn't she be as good as you and take as many classes in vocal coaching, auditioning as you did, as you did? Why does she get off scot-free and doesn't have to do outreach to the people I pay her salary?
Yeah, that's a very, very good question. So thank you for saying I'm very good. I really do appreciate it. I didn't take a single class. I didn't do a single coaching. I make this all up as I go along. And my skills have been developed and honed over years of just forcing myself to do it again and again. As to other professors, other researchers, should they do it? Should they be forced to do it? Yes, they should. I actually think it is an obligation of scientists to communicate their science to the public for exactly the reason that you specified, which is the vast majority of science is publicly supported. And if the results of that science isn't being communicated to the public in a way that they can understand, that is our fault. That is our problem. If scientists are continually surprised why there is distrust in science and a gulf between scientists and the public, guess whose fault it is? It is the fault of the scientists. It's our fault. So no, I don't expect a professor to launch a podcast or host a YouTube series or write a book, okay? But the incentives in the academic world are all wrong. If you are a up-and-coming professor or even fully tenured professor, the way you advance your career, the way you get recognition among your peers, the way you get pay raises within your university, the way you better position yourself within your department or your field is by writing papers and getting grants. And that takes up about 120% of your time. With the remaining negative 20% of your time, you are expected to serve on committees, teach, and then maybe have a family.
Preach, brother, preach.
And I think this is broken. The universities and institutions around the world do not incentivize public outreach and communication. Not necessarily in terms of a financial reward, but they just don't make it part of the package, part of the expectations of a professor or a graduate student or a postdoc. And so no one bothers, or largely no one bothers, because there's no reason to do it. And there's only so many hours in the day. They've already got 50,000 things they got to get done. And continually, scientists run into this roadblock of, hey, we have new science. And then people don't listen. We complain about journalists distorting and running away with our headlines and hyping up bad science. We complain that people aren't paying attention to real science. We complain that people don't understand the scientific method and the scientific process. Well, who's better positioned to teach people than the actual scientists? So what I go around, whenever I give talks, whenever I give a public talk, I try to connect with the nearest university or college and give a talk to their physics or astronomy department and talk about outreach and talk about what I've learned from the front lines and doing this myself and trying to make a living out of it. And what they can do with small slivers of their time so that it doesn't get in the way of their research, it doesn't get in the way of their teaching, it doesn't get in the way of their family, but they can do a small part in communicating science, whether on social media or Instagram or writing a couple blogs or just making themselves available to reporters either on TV or print, of just pushing a little bit to get a little bit more science out there in the public with no one in the middle. So it's direct scientist to public exchange.
You know, for me, I always liken it to, imagine there's an actor or actress and you say, I've got this play, it's called Hamilton. Are you interested in being, no, I don't care. It's just, probably the most innovative play of the last 50 years. We have some of the best material that's ever been created in the entire universe to speak about, the very universe itself, the different aspects of this very smallest structures, the very largest structures, things that border on philosophy, theology. And I always say when people say that, I'm not good at public speaking, I'm good at giving PowerPoint. Well, you probably weren't born good at quantum field theory, but somehow you made it work, right? So it is about effort. The only partial disagreement I have, otherwise we have perfect, mutual admiration society, is that I do think we should, as Galileo said, measure what is measurable and make measurable what is not so. So in other words, if you don't have a metric to appraise or apprize how someone's doing in this realm, as you're saying, there's no incentive. First aspect of incentivization is to have some kind of metric and say, look, this is a component we expected of you. If you're not good at it, we have these things called, trainers. And look, you're proof that you can do an amazing job, build a following, have a fan base. Predominantly, I don't think it's a source of immodesty, but because of the strength of the material and your education that gives you that ability. So the only disagreement I would have is just to say, I think we should train people in how to speak. Look, most of our days, as you said, have to do with writing papers or getting funding, and both of those are persuasion, right? I mean, both of those involve some amount of persuasion. In fact, Jim Simons,
like 90% persuasion. Read any journal article on the archive; it is 90% persuasive.
And we never teach our students this. It's like they're just naturally going to become gifted. I have students that are from all over the planet, and they not English native speakers, and I would send them to Toastmasters, and I would get them up public speaking. And I realized, hey, it doesn't just go to my student from Thailand; it also goes for my student from Illinois and what have you. So I think we're in good resonance there. I want to read a poem since I think science as a form of culture and perhaps highest culture. Maybe we'll get into that when we talk about relativity in just a little bit. It's a poem called Fire and Ice, written by a frosty man named Robert Frost. He said, "Some say the world will end in fire, some say in ice. From what I've tasted of desire, I hold with those who favor fire. But if it had to perish twice, I know enough of hate to say that for destruction, ice is also great and would suffice." What is your preferred method of cosmic or personal destruction?
Wow, this is getting dark. So personal destruction, okay, it's either getting eaten by a hippopotamus or just peacefully passing in my sleep surrounded by loved ones. But when
in
it
the
comes
back
to
of
the
my
Earth,
car, like my grandfather as he was driving.
But when it comes to the Earth, we're gonna burn to a crisp.
So Frosty was wrong. I mean, it was.
I mean, he's not a cosmologist, so he had a 50-50 shot.
Yeah. So I recently reviewed Professor Katie Mack's book, The End of Everything Astrophysically Speaking. And I was musing about, this proliferation. First of all, there's a lot of new work on theories of everything. And I want to talk to you about that. I got a bone to pick with that. But first, what's the eschatological, the fascination with the other side? Normally we think of, the Big Bang, the origin of the universe, maybe cyclic cosmology, however you like to phrase it. And so, but now we're talking about the end of perhaps everything, and there's a lot of books nowadays coming out. What do you attribute that to?
I think it's two things. One is the far future of the universe is a very strange, very poorly understood region of time where physics as we know it is going to completely break down, and we need new laws of physics to ultimately understand it, just like the beginning of the universe. And so all the fascination we had at the beginning of the universe can apply to the end, where just things are going to be different in a very, very strange way. And so I think there's always going to be some set of fascination with that topic. And the cool thing about cosmology is that physical cosmology is we're using science and scientific tools to answer questions that have bedeviled humanity for all of humanity. We've always wanted to know, what is our place in space and time? How did this world arise? Will it transform? Will it end? Will it become something else? What are the rules that govern this existence? This is the basis for like every single cosmological model based in religion and also based in physics. But in the past 100 years, we've been able to start answering these questions using physics and develop the field of physical cosmology and begin to place ourselves in time and space, be able to sketch out the rules that govern the universe, be able to answer some questions about, or begin to start to try to attempt to answer some questions about what the universe looked like in its beginning state. And the very next thing is, well, what comes next? Okay, we got the past, we got the Big Bang, we got the now, we have our universe. Well, what happens next? And so I think it's always going to be a part of the discussion. I think it's always going to be fascinating. That little tantalizing thing that seems just out of reach of understanding is always going to be absolutely fascinating.
Right. It reminds me of this, kind of fascination that Elon Musk has with going to Mars. And he said he wants to die on Mars. And I heard Lord Martin Rees, who graced my book with a blurb, he said, yes, it's likely that Elon Musk will die on Mars. He may die on impact. And I want to ask you, if you had sort of a letter from God, or whoever your deity is, a letter from coffee, I don't know, but you had insurance.
I'll take a Clement bag of donuts. I'll take a letter from him.
Back again. That's right. If you had guarantee you would not die in space, which of the celestial phenomena that you so articulately portray in this gripping book would you most like to get close to and up close and personal?
It's so hard to pick. It's like picking your favorite kid, which is everyone has a favorite kid, but you don't.
My mom used to say,
admit it.
When I asked her, I'd say, who's your favorite kid? And she'd say, oh, that's like asking me to pick, do I prefer my left hand to my right hand? I said, Mom, you're left-handed.
Yeah, left-handed. You have a genetic preference for one hand. Yeah. So, but you don't publicly say which is your favorite kid. But okay, I'll say of all the phenomena that I visit in the book and explore in the book, I am actually very, very intrigued by cosmic strings. I did a little bit of research on them. So there's some lines of professional interest in them. Just seeing a cosmic string, encountering a cosmic string, I think might answer more questions about physics than, say, encountering a black hole would.
You talk about the black hole, and it's not often I get to talk with such an astute observer and knowledgeable professional about black holes, about relativity. But luckily, I talked to Nicholas Eunice the other day. No, I'm just kidding. I'm talking to you now. But I do want to get into a subject that I did bring up with Clifford Will and Nicholas Eunice, who teaches at your alma mater now at Urbana-Champaign. And they have this book called Is Einstein Still Right? I had earlier this year, I had Professor Jim Gates on to describe his book, Proving Einstein Right. Soon I'll have Lee Smolin on my podcast to discuss Einstein's Unfinished Revolution.
And next, you'll have Albert Einstein.
I have Eric Weinstein on my podcast. But you make a lot of Albert Einstein in this book. He's kind of an overarching protagonist in many of these books. Of course, he died with this unfinished revolution, in some sense, this theory of everything. And I want to talk about it because you mentioned things like quantum gravity. You mentioned singularities. What evidence do we have that a singularity even exists to motivate the need for a theory of everything? In other words, putting back on my bag of donuts, Dr. Bag of Donuts to you, if I put that on, it's like, there's no proof of anything infinite in the entire physical world, only in the mathematical world. Why should I even care about a singularity? I don't think they exist.
Oh, that's the exact point. We don't think singularities exist. And the presence of singularities in the mathematics of general relativity that gives rise to black holes. When you figure out that black holes exist and you see that there's a singularity there, that there's a point of infinite density, your first instinct, and the instinct of many physicists 100 years ago, would say, well, then obviously it's wrong, or it's just an approximation, or obviously we're getting something right, but black holes don't really exist. Fast forward a few decades, we realize that black holes do exist. And as the decades have progressed, resulting in the latest Nobel Prize, like, black holes really are a thing. They really do exist.
Although the citation to my friends and guest, upcoming and past guest, Sir Roger Penrose, is for, and to Andrea Ghez up the road here in University of California, is for a compact object at the center of our galaxy, not a black hole. What do you make of that?
Okay, fine. Like, I'm not gonna get into semantic arguments with the Nobel Prize committee.
I have enough problems with them as it is.
But like, it's about black holes, and this is not the first Nobel Prize awarded for something related to black holes. And so we're like, okay, black holes exist, and they keep doing all the things that general relativity predicts them to do. And they keep behaving in the exact same way we predict, the exact same properties. And so we keep realizing that black holes are real. But all the math we have about black holes tells us that there is a singularity at the center. There's a point of infinite density. We know that's wrong. We know that that is a point where the mathematics of general relativity is breaking down, but we don't know what to replace it with. And that becomes a major sticking point. And that's where we want to figure out, like, okay, if black holes exist, like, what's really at the center instead of a singularity?
That's right. And I think the thing that speaks to me so much about your book, in contradistinction to some of the more flowery whiz bang, this is so amazing, is that, you're presenting these, you're also an academic, and it shows in the book with, 10 pages of endnotes, follow-up resources, but that you freely admit. At some points you say, and it's fun to hear your voice live, but after listening to you for the last 13 hours straight on
I'm sorry.
a Sutter binge as I slept. But the point is, you bring up all the things we don't know, and that then you say this wonderful kind of imprecation, but mixed with a blessing, which is go explore. And what about, these phenomena still are left to explore? I mean, Nobel Prizes equal solved, settled science, don't they?
Well, the book isn't to drive future Nobel Prize explorers. The book is meant to drive curiosity and wonder. And we don't, even things that are close to home, even phenomena that we are familiar with on a daily basis, like the sun. There are still many unsolved mysteries about the sun or about the distribution of comets in our solar system. Like we're not 100% sure that the Oort cloud exists. We think it exists because we think comets have to come from somewhere, but we don't know exactly where it is, how big it is, its distribution, any of that. Everything we encounter in the universe, even things that we have a lot of answers about, are still full of mysteries. There is always more to learn, and there are always surprises around the corner. So in some cases, like black holes or cosmic strings, the mysteries are blatant and obvious because our physics breaks down and nothing makes sense. But really, mysteries are everywhere, and they're usually very quiet and very subtle. And they're only there for those who are willing to look for them.
Yeah. And I had this conversation not too long ago with Juan Maldacena at another institute. He's institutionalized also. And we were talking about one of his recent papers called Humanly Traversable Wormholes. And you tangentially bring this up in the book as well. And I asked him, why should Joe Bag of Donut? No, I didn't bring that guy up because I don't think he'd. I'd say, why did Juan, Empanada, someone that he loves from his homeland of Argentina, why would he care about these things when we don't even know if the Randall-Sundrum, ADS-CFT Model 9 or whatever it's predicated on exists? And he said something very interesting, in the context of learning about quantum mechanics from wormholes, learning about, as you talk about, Einstein-Rosen bridges is another name for them. And he said, you can learn a lot about something that may not exist, which I found really fascinating. It's kind of the opposite of your side. Like we know that we know comets exist, as you just said. We know, but we don't know, where is their stable, where is their birthplace, if indeed that is how they come about, as well as some of the other phenomena that were once unknown and unknowable, T-Tauri stars, all sorts of other things that we might not have guessed, type 1a supernovae and how they become important. And I want to ask, just getting back to your academia in the final few minutes before I ask the standard list of questions that I ask all my guests, including who you're going to vote for. No, I'm not going to ask you that. But I want to ask you, in terms of the academic side of things, I asked Nicholas Eunice, who's a fellow Argentinian of Juan Maldacena, I said, what was the most inspirational event in your field? And he didn't say discovering gravitational waves. He said when Pretorius came up with this vast supercomputer simulation of the coalescence of black holes and ring down, et cetera. What is sort of your eureka moment, your wow signal, as you talk about in the book, for you specifically, Paul? What gets you excited, gets you interested? And because we can't do it all, we only have 120% of our time, to dedicate. So what gets you excited about astrophysics, the research side of your vast mental capaciousness?
Yeah, I wouldn't point to any one particular moment, but a daily waking up in the vastness of the universe, in the sheer joy and incomprehensible beauty of the fact that I can sit here at my desk with my computer, with my chalkboard. I could be having a conversation, writing down equations, solving them, running simulations, performing analysis, doing all this sciencey stuff about a particular physical system known as the entire universe, where I can sit with a cup of coffee and discuss with a colleague an event that took place 13.8 billion years ago, and we can keep totally straight faces, and we're grounded in the evidence, and we're trying to analyze some particular part of the signal, or when we talk about voids, like, oh yes, we developed a new mathematical technique for identifying voids. These things are minimum 80 million light years across, and we can just sit here and talk about them the same way we talk about breakfast cereal. That the almost the absurdity of it is what powers me. Like, we actually get to do this? All right, then let's do it.
Yeah, and we get paid for it, some more than others, at those fancy schmancy institutes that you are institutionalized at, and a state employee. Well, I guess you're a state employee too. You just have a different governor that is your boss. I want to close with the three final into the impossible questions that I love to ask. First of all, you may be familiar with the Sir Arthur C. Clarke, who is the namesake of the Arthur C. Clarke Institute for Human Imagination here at UC San Diego. And I am the co-director of that august institution, or society, or center rather. And in the movie 2001, A Space Odyssey, which was a future forecast in the 60s of what life in 2001 might look like. Have you seen that movie, Paul?
I have. It's a wonderful movie.
It is. And so there are these ominous sort of devices, machines, some say, these monoliths that make appearances, opening scene on the plains of the savannah of Africa, encountered by some primates, later encountered on the moon. And in some sense, they're meant to represent a long-lasting time capsule produced by an intelligent alien civilization. I want to ask you, if you could make a monolith, if you could put the Sutter monolith somewhere, and it would be discovered by an intelligent species of something, maybe 1 billion years from now, what would you put on in about that time capsule?
Oh, good question. I would actually probably put art. I would probably put poems and paintings and music. And I would put like mathematical proofs in there. I would assume that a species 1 billion years from now has figured out all the physics and understanding of the cosmos that we've come to, and more. And so I think our feats of technological progress would not be very impressive to them. But where our imagination goes, how our imagination and curiosity has driven us, how we've refined it through so many beautiful fields like science, like dance, I think would be of great value.
The next question also involves Sir Arthur C. Clarke, and that is looking backwards in time. What Sir Arthur is famous for his quips, for his aphorisms. The first one, most famous one being, and we open every show with this, with him actually reading it. It's pretty amazing. My producer, Stuart Wolkow, found him a clip of him reading, any sufficiently advanced technology is indistinguishable from magic. That's Arthur C. Clarke's first law. And the second law, and you and I resonate with this, I'm sure, for every expert, there's an equal and opposite expert. And then number 3 is the only way to find out what is possible is to venture beyond the limits of the possible into the impossible. And that's sort of how I got the name for this podcast. And I want to ask you, to a 20-year-old Paul Sutter, what seemed impossible, but now is eminently doable because you went ahead and did it?
Oh, yeah. Everything about my current situation in life would have seemed impossible to 20-year-old me. I wasn't even a physics major when I was 20 years old. I was in computer science. And it wasn't until my junior year, shortly after I turned 20, that I switched majors and became a physicist. And so the concept of having a PhD in physics, the concept of making progress and in a scientific field, the concept of having a podcast and like doing TV shows, I would have not understood future me.
Yeah. And you think about, a scientific paper that you and I write might take a week, a month to write a single sentence and be read by 10 people, if that, and that includes our co-authors. But your book—
it does not include our co-authors,
and they don't read anything. All right. And then your books, Your Place in the Universe and How to Die in Space, tens of thousands of people read it, and many more buy the audiobook and the Kindle edition, hopefully. And so, yes, it is kind of magical that we're able to do this and reach across and have the impact. I say I outsold, I got a bigger advance than Nietzsche, and so that's saying something. But in reality, you reach so many people, and that brings us to the end of our questions. And I want to give you an opportunity. You talk a lot about angular momentum in the book and the sheer power of angular momentum. No pun intended. Now I ask you to enter the spin zone, and please plug where people can find the Spaceman.
All right, you can go to my website, which is pmsutter.com, or you can just Google search Paul Sutter, it'll come up. And from there, you can get links to my podcast, Ask a Spaceman, my weekly radio show, Space Radio. You can get links to both my books, Your Place in the Universe and How to Die in Space, both, and those are available on Amazon and Barnes & Noble, all the usual. You can also get autographed copies from my website. You can also get links to my show on Discovery Digital. It's called Space Out, and it's really, really fun. Also links to all my articles on space.com and Live Science and Universe Today. Links to all sorts of cool science and art projects, like a project I do with a dance company here in New York, a project I do with a Emmy-nominated composer here in New York, all sorts of cool science and art projects. Just go to pmsutter.com. It is the hub. I put everything there.
Everything is there. Everything rotates around it, not unlike an RR Lyra star accreting composition from its neighbors. Professor Paul Sutter, it's been a thrill, an honor, and a pleasure. I hope to get this out before perhaps the Earth comes to an end. Hopefully not in the next few weeks. Thank you so much for coming on the Into the Impossible podcast.
Thank you so much for having me. It was really, really fun.
Any sufficiently advanced technology is indistinguishable from magic.